This is the Insurance Institute for Business and Home Safety's Disaster Discussions podcast, where we explore the intersection of weather and the built environment. Every summer, interns and fellows join IBHS for a jam-packed Summer of Science at our Research Center campus in Richburg, South Carolina, and at our office in Tampa, Florida. In part 2 of this special podcast episode, we'll hear from the rest of our 2025 group. We're joined by Sarush from the University of North Carolina, Charlotte, our Standards and Analytics Fellow. Welcome to the podcast.
Thank you.
So just start out, tell me a little bit about yourself.
Well, I'm a PhD candidate at University of North Carolina at Charlotte. So I'm studying infrastructure and environmental systems, programmed by Civil Engineering and Environmental Department. So, and basically, what I'm doing is mostly related to energy and environment systems engineering impacts. You said energy, environment, systems impact. Yeah.
Okay. So what does that mean exactly?
Well, a part of that basically related to safety and mostly the connection between these kind of infrastructure to climate change.
Okay, interesting.
And severe conditions. So what I'm delving into is battery energy storage system safety and specifically fire safety.
Okay, specifically fire safety. So you're in the right place for that this summer. What was some of the work you've been working on here at IBHS this summer?
Well, the story that I end up with IBHS is kind of interesting because, as I mentioned, I was working on battery energy storage fire safety, and I had a visit last year to IBHS for one of our PhD level graduate courses, and we saw what's going on in IBHS and testings. And when I saw the wind tunnel, I told myself, well, I gotta find out what's going on here. What are they doing?
Sign me up, right?
Yeah. So this year I applied for the internship, and I got for Standards and Analytics Fellowship, and I'm here right now.
And here you are.
Yeah.
All right. Well, I'm glad that little field trip brought you back into the IBHS orbit. So when you say fire, are you talking about wildfire specifically, or just any type of fire?
Well, what I did here in IBHS was going and delving into Los Angeles fires. So we know that those kind of fires are wildfires. So what I did in IBHS for this summer was researching on wildfires, causes, and specifically related to Los Angeles fires.
Yeah. Well, what are some of the questions you were hoping to answer?
Well, mostly related to structures and buildings. So we have different elements that are related to wildfire regarding to the buildings. So mostly I was looking to develop a risk framework for assessing what kind of elements of the building envelope can be most vulnerable in exposed to wildfire. So we're assuming that, okay, we have a fire in the neighborhood. Each buildings have different elements. Which of these elements for each individual structure can be the most vulnerable thing about it. So what we have is the building specific materials, the openings conditions, we have vents, we have gutters conditions, and we have fuel attachments surrounding the buildings. So these are all can be a main cause of fire. Are we going to make sure that we know about it? That which one was 100% the cause of fire? Some case, maybe. A lot, no, because it's pretty uncertain. But we can go and see that, and which in post event deployment data, with the post event deployment data, we can see that which of these had the most contribution. So maybe we can, in the future, we can recommend something for the different neighborhoods that, okay, so it's better to not use a combustible dick for your when you're constructing your houses, or you should fully enclose your eaves and things like that. Use the double pane windows.
Exactly. Yeah. So we've already done a lot of this research in the lab, and we've kind of pinpointed some of those home components that make a home more vulnerable. But it's always very important to look at these events in the field and learn even more from these real life events. So you looked at homes, I take it, that were damaged in Palisades and Eaton fires out in Los Angeles. And yeah, what are some of your main takeaways from your research this summer?
Well, the main takeaway is that mostly in the different regions, the fire will act. I think that the fire will act differently. But the main thing is to always be prepared by following the standard situations and conditions. So I think we need to delve into these kind of wildfire research more to find out which would be our prioritization to um, tell people to go and make some amendments if needed, or from the scratch build their homes with these kind of conditions to be more safe.
Yeah, that's a big part of our work. Besides our research, we're also working in the code and the policy space to improve these codes and the way that homes are built in wildfire prone places like California. So, yeah, as far as being our standards and analytics fellow, is that if you were, if you were working in the code space yourself, what parts of your research that you've learned this summer would you try to get input into some of the codes in some of these wildfire prone areas?
Well, mostly I think that we need to review the spacing between the structures, which we call it the space of the clearance space. So, and also the another part is that fuel attachments surrounding the each structures are really important, because when a single structure catches fire within the conflagration area, these fuel attachments can transfer the fire from the first building to another. So I think mostly we need to uh, be more cautious about the combustible materials that we have within our um, surroundings and the building surroundings. And also for the codes, we definitely need to see what we can do about revising the structural clearance spacing within each regions.
Awesome. Well, sounds like you did some impactful work this summer. What do you hope to do from here? Where do you go from here as you continue on in your schooling and your research?
Well, most probably I'll be defending my PhD next spring, and I'm really looking forward to work on climate change severe impacts, whether on any kind of infrastructure, most specifically energy, homes, businesses. But that's what I'm doing right now, and hope to follow within the next few years.
And in that space, what kind of accomplishment would you like to achieve, or what would you like to do in that space?
Well, definitely, if we can make our infrastructure more resilient to these threats, that nature will impose us. So that would be the main goal. So I really hope to step on this area to at least have some meaningful thoughts on it to see how we can be more resilient. And if we got into nature trouble, as we can say, how we can get back sooner.
Yeah. So that's certainly your work. It sounds like your work directly ties into what we're already doing here at IBHS. So, what do you think is our biggest vulnerability when it comes to infrastructure as our climate does continue changing? What are some of those key areas that we need to address?
Well, if you it it differs between what kind of infrastructure are we talking about? Are we talking about the fundamental infrastructure, energy infrastructure? Are we talking about residential infrastructure like a region, home, businesses? So it's different between these kind of infrastructure, but mostly operational ability needs to be continuous for each of them. And I think when we call operational ability for homes, specifically homes, it means that people needs to live, continue to live in their home in a safety manner of speech after any kind of disaster. So we need to go forward and see what we can do to bring that for the people that even if because we cannot control these kind of disasters, these are nature-based disasters. We have wildfire. We can mitigate, put some mitigation, but we are not sure what is happening. So what we can do is to be more prepared and make people to be more prepared for these kind of situations and make their home more resilient so that they can get back to their lives and live in their safe zone, or for businesses, or either for energy infrastructure, as we can call it, operability or operational ability.
Yes, exactly. That's what we're trying to do here at IBHS is get out ahead of these disasters and make more resilient homes and businesses. We want to get them out there so that you're right. After the next disaster comes, they can go back to life and continue operating as normal. Well, Saroush, thanks for joining us this summer at IBHS and best of luck.
Thank you.
All right, I'm joined now by Mohammed Issa, a wind-driven rain fellow from Florida International University. Welcome to the podcast.
Yeah, welcome.
So tell me a little bit about yourself, first of all.
So I'm Mohammed. I'm from Egypt. I'm a PhD candidate at Florida International University, and I'm also a research assistant at the Wall of Wind, which is one of the biggest wind tunnels in America that can simulate up to Cat 5 hurricane winds.
Oh, really? So you guys can surpass what IBHS can do at the Wall of Wind?
Yeah, we have the strongest wind we can ever simulate in any wind tunnels in America, in North America.
In North America. Okay, that's really cool. So what are you working on with your PhD work there?
Yeah, I'm working on the wind-induced effects on the structures under hurricane and some thunderstorm winds.
Okay, so the effect of wind on structures from hurricane and thunderstorm winds. That sounds pretty interesting and pretty tied into what we do at IBHS. So naturally, I think you would find yourself here. So you did say in your presentation, you're doing something a little new, though, wind-driven rain.
Yeah.
You've done the thunderstorm and the hurricane wind, but now you're adding the rain in there as well. So what made you want to do that, and what has that been like?
I'm also exploring to add a new skills to my suitcase as I walk down the PhD journey. So this was a really good opportunity to add the wind-driven rain skill to my suitcase. So that's why I chose IBHS to spend my summer at.
And you use some of the data from our PIC tower or wind tower that we deploy out in front of the path of hurricanes. Yeah. So tell me about some of the storms that the data came from, first of all.
So I worked on 4 different events: Hurricane Helene and Hurricane Dabia and Hurricane Francine, and also Hurricane Idalia. All of them are Cat 4 hurricanes, except the Hurricane Francine, which is Cat 2. And I worked all this data to try to figure out what's going on during these events in terms of the wind and wind-driven rain, and to extract the wind parameter that we need and the rain parameter that we need in our IBHS for rain tests.
So you said you wanted to extract the wind and the rain parameter that we need for testing here at the lab with our own chamber?
Yeah, in the big chamber and also in the driving rain lab, the small chamber, we used only to try to test some building components like a door or just a window. We have two test chambers. One is the big one, as you know it, and the other one is just for the building components.
Yeah, our wind-driven rain or driving rain lab, as we're calling it, kind of newer. We're going to be testing windows and doors and things like that, and that's important because we want to know, how wind-driven rain from these hurricanes, affects building components. When people encounter a storm and they get rain in their house, that can cause damage. So, you got to work with Cora on this as well. So, talk about some of what you've done with the driving rain lab this summer.
So, driving rain lab has two important components, which is a build is that the machine that can simulate the wind pressure on the component, and also we have a sprinkler that can spray the water on that component. So we have an issue that been persistent for the long time. Like I cannot remember for 2 years. I think 2 years what the build is. So in this summer we figured out and we solved that problem for good. Me and Ali and Cora and Maury as well, trying to figure it out. That's why now we can move on and try to conduct some tests without any problem that may face our encounter in the future.
Yeah, so tell everyone what the PLA is and what it does.
PLA is like a pressure actuator that take whatever pressure data you get from the field and try to mimic that on the components. So that's why you have some sort of what's happening in real life, but you're having here in your lab. So you kind of simulate a realistic condition on the component door or the windows so that you can get some insights how much water comes in during that event and inform these insights to insurance members or the manufacturer of that door or window.
Yeah, so instead of just kind of randomly, turning on wind and rain, we can take data from actual storms and recreate it here by inputting that data and then saying, if this house had experienced Hurricane Francine with this type of window, this is what they could expect to see from as far as damage goes.
Exactly. To be in alignment with what's really happening in real life.
Yeah, and so you've gotten to work in 2 different wind tunnels now, but why is it so important to have this real world data in your research?
Because, as I said, you need to be in alignment with what's really happening outside there. Because at the end of the day, if you're trying to simulate some severe condition on that component of the whole building, no one can say, "Oh, you already made up this situation." But if you come up with the real data that you have from the hurricane or whatever event you recorded, you can say, "Oh, that's really happening," and we can encounter that in the future. So we should be prepared for that.
Yeah, so you said you solved the issue with the PLAs, you worked with a driving rain lab. Talk about some of the other work that you did that we haven't gone into yet.
All that work it seemed like easy to do, but behind all that work, there's a lot of days we spent on develop that MATLAB codes to try to process this data we get from the field, because the data are mass and that we have the big sets of data that needs a lot of MATLAB coding. That, as I said, I have developed like 1,200 MATLAB coding lines so that we can process the data and can put it in a structured way that can be used by other members in the future.
So 1,200, you said, lines of MATLAB code?
Codes, yeah.
Wow, that sounds like a lot.
Yeah, it takes like 40 minutes to run just for one event.
40 minutes for one event.
Which is a lot in terms of processing data.
Wow. So I want to talk more about the wall of wind. Do you guys do full-scale stuff there, or how does it differ from what we do here at IBHS?
I think we can do a full-scale start, but up to a certain scale. But here in IBHS, you can do one-to-one, which is the exact dimension of the building. You can do it here. But in the wind tunnel and in the wall of wind, we have like a limitation on the dimension because we have some limitation of the test section. But here you have bigger test section. That's why you can test much bigger buildings than we can do. But we have a higher wind speed. That's what gives us edge over all the wind tunnels in America.
Okay. Well, they both sound pretty cool to work with.
Yeah, exactly. So I have both now and on my CV. So that's really awesome.
Yeah, that is really awesome. Well, what do you hope to do from here? Do you think that any of the research you did here at IBHS will that help you in the future, or will that tie into any of your studies that you're doing down in Florida? Or where do you go from here?
Actually, working in here broaden my skill sets by adding the rain to the wind, because my background is only about wind, whether it's hurricane winds or thunderstorm winds. But now I can add rain to it, so that can give me open up broad opportunities in the future for me, because I have experience in both of them or both of them together. So that's why it's open a new horizon for me in the future.
Is there anything that surprised you about the rain component?
Yeah, I think because, as I said, I didn't have any experience with that before, so I never think about it. It can cause more damage or damage as much as the wind itself. So that's why it gives me a new opportunity to look at the same events, like hurricane events, but from a different angle.
Yeah. One thing we've definitely learned here is that the rain factor really can amplify the damage that people experience.
Yeah.
What was your favorite part about working at IBHS overall?
I think one thing that stood out for me is everything is organized, and also we have unlimited resources in terms of research. So that if you want to do some crazy idea or some awesome idea, you think about it. You don't have to wait a couple of years to get fund to work on that idea, but you can do that right now, which is give you edge over the other people because you have an initiative to do first before anyone else. But in academia, I think the only issue is doing whatever ideas come to your mind is finding the fund first.
Yeah,
which is we already have it here. That's why working here is a fortunate, to be honest. It's fortunate to be working here.
Yeah, we can fast track things. Okay, so do you have any crazy ideas that you would want to try if you worked at IBHS?
I think, it's related to the hurricane deployments. We can really improve how we get this data, and we can have a robust data that can stand. And we can also add some measuring device that can stand, can withstand with the severe condition we have during these events.
All right, awesome. Well, thank you so much for joining us at IBHS this summer, and best of luck.
Thank you.
Hey there, Dr. Ann Cope, Chief Engineer for IBHS. What is the best roof? That's a question we get asked a lot here at IBHS, and the answer is complicated because it depends a lot on where you live. Roofs should stand up to everyday thunderstorms and limit the damage from oncoming hurricanes. With our Roofing Roadmap strategic initiative, we're making the IBHS science about weather and roof performance available for you. Visit ibhs.org/roofing roadmaps and take our Roof 101 course right now to learn about asphalt shingles, America's most popular roof cover. How well does your shingle roof stand up to wind and hail? What do you need to know about roofs? Get the science at your fingertips today, ibhs.org.
Right, I'm joined now with Pramadit, our Wildfire and Reliability Fellow from the University of Nebraska, Lincoln. Welcome to Disaster Discussions.
Thank you. Glad to be here.
Yeah, it's been awesome to have you at IBHS this summer. Just tell everybody a little bit about yourself.
I'm originally from Nepal. I did my bachelor's there in civil engineering, and then I got an opportunity to come to US, and I did my master's at Colorado State University, and then I moved to Nebraska to pursue my PhD. For the PhD, it's mostly on hazard side. So, yeah.
Well, you're in the right place if you're looking to study hazards. So you did some work. I guess when I asked, did you do anything with wildfire previously before coming to IBHS? Because I know you worked a lot with wildfire this summer.
Yeah, but I didn't do any wildfire research before. My main area of focus was wind mostly. So I was looking at mostly tornadoes. But then my professor, he likes to explore different hazards, and our lab is set up such that we do research on multi-hazard. There are other PhD students in our lab who do seismic, flood. So it's just exploring new hazards, and I find that this opportunity that I had at IBHS that he mentioned to me, I like that idea about coming here, doing hands-on work on fire and bring that back to like my PhD itself. So.
Yeah. So tell me a little bit about your project this summer. I know you worked a lot with the cone calorimeter, which we use for material flammability testing here at IBHS. Really interesting and very unique tool. So what did you set out to try and learn this summer?
So in the fire side, there has been a gap in terms of quantifying the resistance of some of the materials, especially in the wood structures. As like most of the like house residential buildings in the US are wood structures, right? So we have that lack of data in terms of resistance. So the main objective was to try to quantify that just using the cone calorimeter. And it has some level of uncertainties, some limitations that comes with it. And so we tried to like work around that and designed an experiment that has given us some initial results. And we're going to use that result to inform our next decisions in designing another experiment that is more in line with the actual like fire we see in ADUs or like actual fire in the urban areas. Yeah.
So what were some of your results that you found?
So what we found out was very interesting, that the load that we got from like the ADU experiments, like this from the data that we gathered from the sensors, right? From that we developed a load curve for the fire. And then from the cone experiments, we were able to develop the resistance curve. And one interesting thing is that the resistance we found was 3 to 4 times like higher, 3.5 times higher than the load that we see in the actual fire at the ADU. So that's a problem that we're trying to solve.
So just break this down a little more for us. What is a resistance curve? What does that mean?
So it's just like a histogram, right? Like, so you taste one sample and then, for example, let's say that sample ignites at 60 heat flux and you taste another, right? It ignites at 62, right? So, and then you count the number of samples that ignite at each of the heat flux and you bin them and then you get a curve, like a histogram. So that would be our like a resistance curve.
Yeah, and talk about the importance of understanding, the different types of material and how they're able to perform.
So, because so this will give us some idea of, for example, if we right now we did the experiments on wood siding samples, right? So if we are able to like quantify that, then we know that, okay, this type of wood sidings are able to withstand this much, let's say, heat flux or this much heat load, fire load. And we can make suggestions to like home builders, right? Or even like codes and standards that, okay, this should be at this level to be able to resist that much heat.
Right. So we're trying to really quantify that threshold for when this combustible material is actually going to catch on fire.
Yeah.
Okay.
Yeah.
And so the unique thing about the cone is that it's a controlled, repeatable environment, right? So you can do as many experiments as you want. A lot different than our ADU when, we only have one house a day to set on fire out there. So tell me about that aspect.
Yeah, I mean, even in the cone, even though we can do a lot of experiments, so the limitations I mentioned was that we cannot go above 70 kilowatt per meter square heat flux. So that's gonna limit the experiments that we're gonna be able to do, right? So we have to look for other clever ideas on how to do that. And I think like we have one instrument for us mentioned that it's in like Melbourne, Australia, where they have a radiant heating panel like that can move back and forth so that you can like vary the heat flux, right? Rather than the cone where it's at a constant constant heat flux. And you cannot like vary the heat flux also in the cone. So that's another limitations. So those limitations hinder us to actually like quantify that fire resistance. So small details that we learned from this experiment we're going to translate to the new experiment where we can do the variable heating. And I just came from a meeting with Faraz, Ali, like that group where we're trying to figure out another method of like how to do that experiment, because in fire science it's not as easy as like wind and earthquake, because if you subject a sample to a heat, then it cannot turn back, right? Like it has lost some of its mechanical, chemical, ignition properties already. It's not like the steel bar that I mentioned, that like if you subject the steel bar to some strain, and if it's not beyond its like yield point, then it can again come back to its previous state. So for fire, that's not possible, right? So we have to be very clever in designing that experiment, and we're still in talks, about like how we can come up with an experiment that can, quantify.
Yeah, that's really interesting because it's fire, it's undergoing a chemical change. So it's changing everything about it.
Yeah.
You only get one shot to do that, mm-hmm. right?
Yeah. Yeah.
And then we know in real life and in the ADU experiments, as well, things are not experiencing one constant heat flux. It's changing, it's going up and down. So that's another tricky part, I presume.
Yeah. Yeah. I mean, there's like, if you look at the heat curve, like the heat flux curve from the ADU sensors, depending on the distance also, like for distance, like 10 feet separation, you can see the heat flux like go up very fast, right, on the target building. But for like 40 feet separation, it goes like very slowly up. And we're interested in like the energy accumulation also. But we realize like that might not be a good criteria to look at the resistance, because like you can accumulate energy over a long time, right? Like let's say 1 year, but still it might not ignite even if it accumulates the same amount of energy that you can supply in 5 minutes at once, right?
Yeah.
So there are a lot of like challenges, that we're facing right now in terms of how to design that.
Yeah. Lots of groundbreaking research going on in the world.
Yeah, I think so. Like if we are able to at least like solve this problem, it's going to be huge. Yeah.
Awesome. Well, how does what you're doing here at IBHS this summer, how does that tie into your PhD work?
So my PhD, I'm trying to do like multi-hazard. So because like fire is also a concern in Nebraska also a little bit, not that much. And I have families in Colorado where like fire is a big concern.
Yeah, absolutely.
Yeah, and I live in Nebraska. Like what I'm doing my PhD as Nebraska, right? I don't know where I'll end up, but in Nebraska, the tornadoes, they are the big deal, right? So that's why I've been being involved in like tornado research. But yeah, I mean, this is a new like avenue that I explored this summer at IBHS, but I find it very much interesting than, let's say, tornado, at least like right now, because there's like a lot of gaps that I'm seeing.
Yeah.
And that allows me to just explore different ideas, look at this thing, look at that thing, and then, just
it's always fun to learn new stuff.
Yeah.
Learn about new hazards as well.
Yeah.
Awesome. Well, where do you hope to go from here? What is going to be next for you?
I'm going back to the university, continuing my PhD. And this coming semester, I'll be giving my qualifying exam. So just going back to research again. Yeah.
What was your favorite part about interning at IBHS?
Yeah, it's just if I have to point out just that one incident, then it's the ADU one, just the second day that we came here, right? But if I have to summarize all of these, then it's like working with Faraz and Ali. It has been very fun. Yeah.
Yeah, awesome. All right. Well, thank you so much for joining us at IBHS this summer, and good luck.
Yeah, thank you so much. Yeah.
Now we're joined by Luca Prado, our architectural engineering resiliency intern from Florida Atlantic University. And Luca, you are joining us all the way from our office in Tampa, Florida today. So welcome to the podcast.
Thank you.
So first off, just tell me a little bit about yourself and what brought you to IBHS as an intern this summer.
Yeah, so I'm Luca. I go to Florida Atlantic University, and I spent my second year in college in England. I was doing architectural engineering, and I fell in love with it, with everything that I did there. So coming back to America, I really wanted to do something along those lines. So I found IBHS. I looked at the work that is done here at IBHS. Also, as somebody that lives in Florida, and having experienced hurricane and hail also, it was very, very nice to see a company that was working on something that I have seen so many suffer from. So it was very interesting.
Yeah, and tell us a little bit about architectural engineering, right? We've heard of architecture, we've heard of engineering, but how does that field of study combine both of those?
Yeah, so it's a combination of both. So it's definitely not as focused on the design as it would be with architecture, but it's also not as focused on construction as engineering. So it's a mix of both.
Awesome. And you said you live in Florida. You've dealt with things like hurricanes before, but your project this summer focused on the total opposite. You got to work with our commercial lines team and talk about winter weather. So I guess first tell me, what was your experience like working down at our office in Florida with our commercial lines team?
Yeah, it's definitely a change from the RC. I was lucky to be able to travel to the RC twice during my internship, and which actually my first 2 days of this internship were at the RC. So coming back to Florida for the remaining of the week and seeing the Tampa office is very different. It's more of a corporate feeling, I would say. We're a small team here. So it's definitely a little bit more quiet. I get to have my own office, which is very nice. And yes, I didn't work with hurricane. I did get to learn a lot about hurricane, but this summer I have worked with wildfire. I did a piece on grocery stores and mitigation of wildfire. And the other one, which is the one that I chose to do my presentation on, was mitigating the damage of winter weather in places of worship.
Yeah, and that was a really interesting topic. Just tell us a little bit about what you learned and some of the things that we got to see in your presentation on that.
Yeah, so I've learned a lot. We have many different things that we recommend to our members. So working with commercial, we are basically the bridge between our researchers to our members that are the ones that basically fund IBHS, and our main purpose is sending out the materials and our findings to the public. So we basically put all the data and the things that we make it easier for them to understand through our content and occupancy pieces, and also chatting with our members, understanding what their concerns are and what the issues in the commercial industry that they're facing are, so we can help them and implement some easy strategies that they can use in mitigation of these perils.
Yeah, so you worked on, actually you mentioned in your presentation, over 150 different pieces. Tell me about that.
Yeah, so we started in 2009, and we have pieces up till 2025. So in total, there were 157 pieces, and each year we try to bring something new, or if it's not necessarily something new, it's something that we have updated, because we have different building codes, and we also have different findings that our researchers are finding. So it's always nice to be able to put out pieces so they can get the most updated versions and learn the most from IBHS.
Yeah, so for the piece that you focused on in your presentation, you talked about how places of worship you talked about both simple and more complicated things, or more in-depth things, I should say, that they can do to protect their buildings and their places of worship from winter weather. So just tell me a little bit more about what you learned with that.
Well, what I've learned with that would be it's firstly something that we've never done here at IBHS, working with places of worship, and they are so unique. We worked with hotels, with apartment complexes, we worked with medical facilities, we have worked with educational buildings, but never with places of worship, and they are so unique. Like I said, some of them are over a century old, some of them are newer, and they have, for example, those stained glass windows that are so delicate and so hard to retrofit, and the ones that are older, they most of the times they lack the proper insulation and the proper modern construction technologies that we today have. So it was definitely something a little bit more challenging to work with, and so many of these places count on volunteering to operate, and a lot of the times they don't have the budgeting to do big retrofits and big upgrades. So it's also tricky to work with that. So I try to recommend more inexpensive things that they could do if they don't have like an extensive budget, and more inexpensive things that they could also do. And yeah, just evaluating the things that defer a place of worship to a hotel, for example.
Yeah, well, awesome. Really, really useful stuff that can be put to use, by real people that this will have an impact on. So I want to ask you, what are your plans ahead? What are you going to do next? And how do you think you'll take, skills and things that you learned here at IBHS during your internship into your future with whatever you do?
Well, I really liked it. Was a complete different field from anything that I have thought I'd be working with. Um, Never imagined that there would be such a big space for architectural engineering here, with the different perils and stuff. It's what IBHS does is very unique. You don't find companies that do the same stuff that we do here at IBHS. So it definitely has been a game changer, and it will be a game changer with my career and the stuff that I have learned here, and I can apply and use that to my advantage in the future, which is great. And also, it, like I mentioned before during my presentation, it was really great seeing the insurance part of this, which is something that, when we hear insurance, we think of something boring, just numbers, and seeing how architectural engineering can be implemented in that field is very, very interesting. It's definitely something that I consider in the future.
Awesome. Well, it was so great to have you here this summer, and thank you for joining IBHS. I think I got the chance to talk to you. I think it was at that first ADU burn. By the way, how was that to see that in person?
That was phenomenal. It was the first time that I have ever seen something like that, and just seeing all the people researching it, like in the very moment, calculating stuff and all the programs. The science people, it's very different from what I do and from what I think I could ever do. It's fascinating. So it was very, very interesting to see what I do here, and how it connects to what they are doing there.
Awesome. Well, thanks for joining us this summer, and thanks for joining us on the podcast.
Thank you.
All right, I'm here with Josh Paulson now, our broadcast meteorologist intern from the University of Alabama, Huntsville. And Josh, you actually stepped out from behind the control room, put a microphone on. You've actually been producing and directing this very podcast episode.
Yeah, I have. It's been fun learning all the cool stuff back there, but it feels nice to jump in front of the camera for a little bit.
Yeah, and you've really done a range of things. So you're a broadcast meteorologist intern because you're working on the product design team. We are all former broadcast meteorologists. At the beginning of the summer, you said you might be interested in broadcast meteorology, but it sounds like you have your eye on some different goals as well, and you've worked on a lot of those this summer.
Yeah, so I came in thinking maybe I want to do broadcast meteorology. Did some of the research side of things here this summer, specifically on tornado damages and seeing how Fortified can make changes to that. But I think now I maybe want to go into the more in the moment forecasting, National Weather Service side of things, helping people in the now. One of the bigger things that I want to do is tornado chasing. I know that sounds kind of cliche. Everyone wants to do tornado chasing, but being there, being able to see where exactly the tornado is and helping people, because you know how a radar works. The beam, if you're so far from the radar, you can't see what's going on at the ground. So the people that are actually there are really important to really seeing where that tornado is, where it's going.
Yeah, awesome. Definitely a National Weather Service, great career path as well. Lots of options for meteorology students. We are going to talk about your project. You did a lot of stuff though. So you've helped us in the studio a ton. You know what, we have a million buttons back there. You know pretty much what all of them do at this point. You've helped us run live shows that we've done. You've helped us with photography, with videography. You've been on site really up close, taking photos of the ADU burns. What else have you done? I know I'm missing some things.
I think that really hits everything. I went out to Wilmington for the Fortified Awards for that. Helped out, got some good photography, videography, so those can be used in some products and everything. I helped out in the studio with getting the cameras all set up, making everything look all nice, all the colors and all that. But I think you hit pretty much everything that I've done this summer.
Yeah, you also brought some skills of your own to this internship. You have a little bit of a marketing background as well. So you've done a lot of stuff with graphics making and photography. How has that helped you in your internship with IBHS?
Yeah, so back at school, I'm the marketing director for our lacrosse team. So I've been able to dabble in that a little bit last year. And coming here, I had a background in photography for a few years now. And just being able to have an eye for those things whenever we do the ADU burns, being able to see what is really good to get a picture of in the moment to really show what we're really doing with the ADU burns, I think that really helped me out. And then with my final presentations here at IBHS, having that being able to make graphics, that helped me out a little bit to kind of put forward illustrations of the complex data and information that I'm trying to display to people.
Yeah, there's a lot of information that we're trying to communicate to people, and there's definitely a balance of being able to communicate that, but like not overloading them with too much information, and then presenting it in a way that looks nice and is kind of easy to digest. I know you've worked on that a lot with your PowerPoint that you've been designing.
Yeah, I think broadcast meteorologists are really the key to between the science and the general public. So I think they really have a really special job within the weather community.
And by the way, you're originally from Tennessee, right? And then you go to school down in Alabama.
Yeah. So a little background about me. My father was in the military, so we traveled around a lot. Lived all the way from Alaska to Texas. Ended up in the Knoxville area in Tennessee. And then I've been going to school at the University of Alabama, Huntsville. I'm going into my third year there now, and I am an atmospheric science major there. Yeah,
and they have a great atmospheric science program there. So let's talk about your project. You assessed a tornado from Kentucky, a very notable tornado. And we've done this in some of our so we have our Fortified program, our voluntary beyond code set of construction standards for making a more resilient roof. And we have analyzed previous storms. I know we looked at Hurricane Sally. We looked at some tornadoes from Tuscaloosa. And I guess talk about the importance of looking at these weather events with what we're trying to do and tying it into our Fortified program.
Yeah, so when I came here in the beginning, I didn't really know exactly what project I wanted to work on. But as I spent more time here, I realized that we don't have much. We haven't really looked into tornadoes much with Fortified, and I think that tornadoes are a big thing, especially me being an atmospheric science major. Tornadoes are really interesting. And if you really look at the numbers of some of the bigger tornadoes, I believe El Reno, that tornado, has the record for most expensive. I want to say it's around $2.9 billion for the one tornado. So tornadoes can really cause a really big economical distraught to a lot of people. And so I decided to do a little case study on a bigger tornado in recent times. So I took a look at the Mayfield, Kentucky tornado from December 11th, 2021. That was a EF4 tornado that tracked 165 miles, so pretty long tornado. And really what I looked at is how our fortified program, roof, silver, and gold, could have prevented some of the damages that were seen in that tornado. So when the National Weather Service goes out and looks at these tornado paths and look at all the destruction, they give everything a category on which they fall in with whether it's a strip mall, a house, or trees. And then within each of those different identifiers, they have different levels of damage. So specifically with my project, I looked at the single family residences, so regular everyday houses that most people live in. And that has a scale from 1 to 10 of damage. And what I found is that fortified could have addressed that 1 through 6 levels of damage. And that accounts for 65% of the total damage that was surveyed to single family homes. So that's a pretty big percentage that could have been addressed and could have been saved by fortified.
Yeah, absolutely. We've done some assessments. We've talked a lot about fortified relating to hurricanes, but we're seeing a lot of expansion of the fortified program to inland areas such as Kentucky. And the fortified program, those elements in it, as you've talked about, can help minimize greatly the damage that these homes and inland locations experience from tornadoes and severe thunderstorms. So when you're talking about the damage indicators here, so we're talking about the EF scale, which is that scale used to rate tornadoes after they happened. The National Weather Service does their damage survey. They look at the damage itself. And you mentioned, so there's different damage indicators for things like single family homes and commercial buildings and even trees and all sorts of things. And then within each damage indicator, there are degrees of damage, right?
Yes.
So you were looking at those degrees of damage for single family homes.
Correct. Yes. The damage indicators, there are 28 damage indicators as of right now. And specifically, we were looking at damage indicator number 2, and then that had 1 through 10 levels of degree of damage, with 1 being threshold of damage and 10 being the slab swept clean.
So 6 out of 10 could be eliminated with fortified. Is that right?
Correct. Yes.
That's a lot.
6 out of 10 could have been addressed to some extent. So not making your house tornado proof, but making your house being able to withstand those higher winds to that EF2, EF3 level. Because really what my research project focused on was not minimizing the damage from the EF4, EF5, but to minimize the width of the damage. So specifically in the Mayfield tornado, that was a 165-mile long track tornado, and only a little over 1 square mile of it was actual EF4 damage. So that's less than 1% of the total path that the tornado took. And I think being able to address the square mileage over the other 164 miles that wasn't EF4, I think that would be really beneficial, really monumental to the homeowners and insurance industry.
Yeah, absolutely. So that's really something that's very interesting. So, when you talk about number 10 being the home being swept off the foundation. Obviously, when we're talking about these EF4, EF5 winds, there's nothing we can do about the most extreme of the extremes. But you pointed out it's a very narrow part of the damage path, only about 1 square mile. But there was 100 plus square miles of the lower end winds. So so you're literally minimizing the damage path by kind of eliminating much of that damage on the outer fringes of that tornado path. And that's super impactful.
Yeah, and to add on to that, EF5 tornadoes, we haven't had an EF5 tornado since 2013. So that is 12 years now that we haven't had one. But tornadoes are more frequent than people would think. If you look at it, I believe the National Weather Service has some data out there for every year. I think that there's a couple thousand tornadoes across the continental United States every year. And the traditional tornado alley that people think of with Kansas, Oklahoma, Texas, where all those tornadoes are happening, that actually the frequency for tornadoes out there is going down. and the frequency for tornadoes east of the Mississippi River is actually going up.
Yeah, absolutely. We hear it called different names: Dixie Alley, Deep South Alley, and this is a part of the country that's very vulnerable to tornadoes because of the quality of construction in some of these areas. Some of these areas are very rural. A lot of tornadoes through parts of Kentucky and Mississippi and Alabama, and we can really minimize the damage for that. And most tornadoes, by the way, I want to say the stat is something like 90% plus are low-end tornadoes, EF0, EF1, EF2 level, and we can have homes resilient and able to stand up to those tornadoes.
Yeah, I think it would be amazing within the next however many years to see 90% of tornadoes to be resilient against with the houses, the home community, and some future work for my project that I left in here for the IBHS team here is to maybe do that same kind of research that I did with single family houses and move it over into the fortified commercial and fortified multifamily that we have.
Yeah, that's something that's definitely needed. Lots of, things like apartment complexes and condominium complexes, and we definitely need more information on how we could reduce the damage surrounding those buildings as well.
Yeah.
All right, so you want to chase tornadoes. What's your world domination plan for chasing tornadoes?
Ooh, I don't know. I haven't really thought of that. Me and my friend back at school, actually, we're going to start getting into tornado chasing this upcoming severe weather season. So looking forward to that. We really just want to get cool pictures. Photography side of me wants to get cool pictures.
Yeah,
cool
you take
videos.
some great photos. So that would be a great opportunity.
Yeah, kind of expand my reaches of photography all the way from portraits to tornado pictures. I think that'd be pretty awesome.
Well, you certainly have a range of skills, some of which you've developed here, some of which you already have. So you're thinking National Weather Service for the career, right?
Correct, yes.
Do you have like a favorite location, like a dream destination office you'd want to work at?
I've been telling my parents that I want to move to Washington State after school. So kind of not really tornadoes, but I definitely want to live up in the Pacific Northwest sometime in my life.
Yeah, beautiful place. And every place has unique weather, so I don't think you'll be bored anywhere you go. Yeah,
the United States is super cool. I wouldn't really say lucky, but super cool that it has a bunch of different climate zones within it, so you get different weather across the whole United States.
Yeah, lucky if you're a weather enthusiast, at least, right?
Right, yeah.
So what's been your favorite part about interning at IBHS?
My favorite part about interning here has definitely been being able to work towards something that helps the masses. So being able to do my research and kind of give a reason for Fortified to move inland and give a reason for people that aren't in the hurricane zones along the coast to look into Fortified, look into making their house more resilient to these severe convective storms and all that. I think that's probably my favorite part about working here.
All right. Well, it's been awesome to have you on the product design team. You've certainly helped us out a lot, especially in the studio and with photography, really, really all elements. And good job on producing and directing our podcast.
Yeah, thank you. It's been a blast here. I've loved it.
All right. Well, we hope to see you back here again sometime. So thanks for joining us, Josh.
Thank you.
A big thank you to all of this year's interns and fellows, as well as their mentors that helped to make it happen this summer. You are IBHS. Thanks for listening to the Disaster Discussions podcast. Join us next month for a new episode. For more on IBHS's ongoing research efforts, visit ibhs.org.